All right, so lesson 21A, this is the beginning of Unit 2. Today we're going to talk about how to determine whether a relation defines a function, also to verbally justify why a relation is or is not a function, and then our typical why am I learning this. So the first thing we need to do is to define a few things. I believe you need to finish off the definition for a relation. And a relation is any set of ordered pairs. And in a regular class, we may have to define what an ordered pair is, but we have been around ordered pairs off and on all of Unit 1. An ordered pair is something that you graph on a coordinate plane, so like 1, 2. But a relation is any set of those ordered pairs. And a function is a relation that assigns to each x value exactly one y value. And I believe you've got something you need to fit in on your notes there as well. Some people have trouble understanding what that means. Each x value is assigned exactly one y value. So that means each x value has only one y value, not more than one. So what we're going to do first is we're going to take a look at this in terms of a mapping. And a mapping is just a different way of writing some ordered pairs. So if we follow the arrows here, 1 goes to 6. That's one ordered pair, 1, 6. 1 also goes to 7. That's another ordered pair. And what I'm looking at right now is I'm looking right here, following the arrow. 1 goes to 6. 1 also goes to 7. And then as we can see here, 2 then goes to 7. So that mapping represents 3 ordered pairs, and here they are. 1, 6, 1, 7, 2, 7. So write those in there. Anybody know whether that's a function or not? Is it or is it not? This is what you have to go to. Each x value has exactly one y value. Well, we have to be careful with that because just because it's repeating 1 doesn't mean it may or may not be a function.
It is because there's no repeating. Oh wait, it's not because there's 2 sevens.
There's 2 set, but it doesn't say anything in the definition there about there being 2 y values. Each x value has exactly one y value.
It's not because one of the x values has 2 y values?
Yes, exactly. This x value has this as a y value. Each x value has one y value. But then it says, no, that x value has that as a y value. So that one x value has 2 different y values. But each x value is supposed to have exactly 1. That means 1 and only 1. So what that means is that that one is not a function. Here's the second mapping. This time I have 1 going to 6 and 2 going to 6. So the question in this one, we already answered the first one. The first one is not a function. How about the second one? Is that a function?
Yes, because they both have like one y value.
Yeah. Each x value has one unique y value. Okay? 1 has a y value of 6, and then 2 has a y value of 6. Each x value has exactly one y value. So that one is a function. So part of what we're talking about today is trying to determine if a relation is a function. Before we go a little bit further into that, we have to define some things with regards to ordered pairs. We all know that in an ordered pair, the first number is an x number or an x value. Sometimes that value is referred to as the domain. Sometimes it's also referred to as the input value. And the range are the y values. And the second number in any ordered pair is the y value. Sometimes we refer to that as the range. Sometimes we also refer to that as the output. So here's what I'm saying. An x number is also the domain. It's also the input. The y value or y number is also representing the range and also representing the output. We're going to talk more about input and output on another day. But today make sure you understand. X numbers represent a domain. Y numbers or Y values represent the range. So here I have a set of ordered pairs. This is a relation because it is a set of ordered pairs. What I would like you to do right now is I would like you to, as you can see in your notes, state the domain, state the range, and then figure out whether that is a function or not. I'll give you about 45 seconds. All right, the domain are the x values or the x numbers or the first numbers in any ordered pair. And that would be 3, 4, -3, 0, and -4. In other words, it's all the numbers that are in red right there. All of the first numbers in the ordered pairs. For the range, it is the second numbers or the y values. And that would be -2, 1, -4, 2, and 0. In other words, as you can see up there, it's all of the second numbers. But the next question was whether this is a function or not. Is it a function, yes or no?
Yes.
Are you sure? Yes. You should be. It is a function. Good. All right, let's continue on here. As we progress through this unit, we're going to be tying equations with order pairs, with mappings, and all of those things together. But let's pretend like we have this function y equals 2x. Or this equation, y equals 2x. If I did it in terms of a chart, which is one of the things you were supposed to do last year, and I picked some random x numbers, those would be the corresponding y values. So we have a domain and a range, or input and output. If I translated that over to a mapping, it would look something like this. When the input is -2, the domain is -4, and so on. But the question that I have for you is this. Is that a function? Yes or no?
Yes.
Are you sure?
Yes.
You should be. And really the mapping typically clears that up. And that is a function. Okay? Here's what the graph of that would look like, of y equals 2x. And of course we've graphed lots of linear equations like that. That is a slope of 2 and a y-intercept of 0. Yes?
Oh, there's another mistake. It's just
It figures. Where is it?
right.
All right, let's continue on here. Let's pretend like we have this equation, y equals the absolute value of x. If we were to plot that using a table, just picking some random x values and then plugging those in and figuring out the y value, that would look something like this. In terms of a mapping, looks like this. And of course, I'm about to ask you this. Let me finish the mapping first. Is this a function? Yes or no?
Yes.
Yes, it is. All right. And here would be the equation x equals the absolute value of y. I'll do a table first. I'm picking y values this time and figuring out what the x values are. Let me do that in terms of a mapping really quickly. And I believe in your notes here, you're supposed to be drawing out the mapping there. So let me finish the mapping, and then I'll stop for a second to let everybody get caught up. And then I will have, of course, a question for you as to whether this is a function or not. So go ahead and get caught up on the mapping first. All right, question for you. The second problem, x equals the absolute value of y. Is that a function, yes or no?
No.
No, and really the mapping sort of clears it up. And the issue, we've got several issues right here. This is one of them right there. The x value has two different y values. It's not supposed to have two different. It's supposed to have a one for each one. And then we've got another problem right there when the domain or x is 2. So that one is not a function. Okay, so let's really quickly, I'm going to show you what the graph of y equals absolute value of x looks like. It looks like that. And I'm showing you these because this is where we're transitioning next to graphs. Here's what the second one looks like. Looks like that. We are about to do graphs like the one on the left-hand side. The ones on the right-hand side, that's typically saved for Algebra 2 or possibly Integrated 2. All right, quickly, turn to your shoulder partner. What have we discussed so far? You got about 20 seconds. All right. So if we have ordered pairs, pretty easy. But what if we don't have ordered pairs? What if we had a graph instead? And that's why I was showing you those graphs earlier. There's something called the vertical line test. And here's what the vertical line test, and this is another part where you have to fill some things in. Vertical line test says if a vertical line crosses the graph of an equation only once, then it is a function. So what that should mean to you also is that if a vertical line crosses your graph more than once, it's not a function. And I know that these are already drawn out for you, but my example here, the orange line on the left, that one is a function because no matter where I draw a vertical line, it's only going to cross that graph at one point. That means it is a function. However, in the example on the right, if I draw a vertical line, for example, right there, you can see that my vertical line crosses that orange curve at more than one spot. If a vertical line crosses it once, it is a function. If it crosses more than once, it is not a function. So if you have a graph, it's extremely easy to determine whether something is or if a relation is a function or not. All right. You have all of these graphs in your notes already, but let's just go ahead and look up here and then you can translate it over. This graph right here, is that a function, yes or no? Yes, and watch. I'm going to rotate a vertical line all the way through, and no matter where that vertical line went, it only would cross that red line at one spot, so that is a function, by the way. That is the function y equals 1/2 x plus 2. How about this one right here, this horizontal line? Is that a function, yes or no? Yes, it is. Watch, I'm going to put another vertical line rotating all the way through, and no matter where that vertical line went through the graph, it would only cross at one point. Therefore, that is a function. By the way, that is the equation of that line is y equals 4. Here's another one. Anybody have any idea whether that is a function or not?
No.
Yeah, and that's the most commonly missed graph in terms of determining whether it's a function or not. Because people think, well, it only crosses once. Really? Watch, here goes my vertical line. That blue line crosses at every single point on that graph. And there are an infinite number of points on that line, therefore, it is not a function. So don't make that mistake. A vertical line is not a function. Now, one of the questions I have up here is why? And I'm kind of explaining them along the way, but the reason why this one is not a function is because of the vertical line test. It crosses the line at more than one spot. That is x equals 5. All right, here is what's called a parabola. Is that a function, yes or no?
Yes.
It is a function. I'll rotate another vertical line through there. No matter where that vertical line goes through, it will only cross at one spot. So therefore, it is a function. That is the equation of that parabola is y equals x squared minus 4. Here is a sideways parabola. Is this a function? No. And right there is an example. That blue vertical line crosses the graph at more than one spot. So it is not a function. By the way, the equation of that sideways parabola is x equals y squared minus 5. How about this one? What? Yes, it is. This is what we call in later math courses a piecewise function, because when x is less than 0, it's one thing, and when x is greater than 0, it's something else, so it looks like that. Not that you have to worry about that right now, but in later math courses you will. How about this one? Function, yes or no?
No.
No, we've already taken a look at one that's kind of like that. And how about this one right here?
No.
No. And once again, this is a circle. You graph circles typically in an integrated 2 or integrated 3 or perhaps algebra 2 or pre-calculus class. That is not a function. The equation of that would be x squared plus y squared equals 9. All right, so far we've talked about how to determine whether something is a function based on order pairs or mappings, and also with the vertical line test. Quickly answer all 4 of those. And I want you to give a quick sentence as to why, if something is not a function, why it is not a function. So I don't anticipate the yes or no part being the difficult part. I think what's going to happen is some of you are going to either conveniently forget or not know how to explain. So I'm going to go through each one. Obviously, number one is a function. And the reason is because each x value, remember the domain represents the x value, the range represents the y value. Each x value has exactly one y value. That's the reason why that is a function. Number two is not a function because each x value does not have exactly one y value. -3 has 4 different y values there. That's not exactly 1. That's why that's not a function. Number 3 is not a function because of the vertical line test. A vertical line, if you were to draw it, for example, right here, crosses at more than one spot. That's the reason why that one is not a function. And number 4 is not a function. And the reason is because each x value does not have one unique y value. -2 has 2 different y values. Remember, input and output, another way of phrasing x values and y values. All right, let's go to number 5. In later math courses, this is called a step function. Why a step function? Because it looks like steps or the tops of steps. So the first question for this one is this. Is this a function? Is it? All right, we got some yeses and some nos. Quickly turn to your shoulder partner and exchange answers and explain why.
Wait, do they have open dots for the steps too sometimes?
All right, bring it back up front, please. Somebody's looking ahead. Who's pretty sure of whether this is a function or not?
I believe it's not a function.
Why?
Because it may cross, or it can cross more than.
Okay, I'm glad you said it can cross. That's a common way to phrase the vertical line test. When you say it, I don't know what you're talking about. It may cross more than once. What's it? Not just a line either. The vertical line. You have to state that it's a vertical line. When you say it, I don't know what you're talking about. When you say a line, you might be talking about that line. That line doesn't cross the graph at all. So we have to be a little more specific on that. We are talking about a vertical line. And it is not a function because if I draw a vertical line right there, it's going to cross here and here. So this one is not a function because of the vertical line test. Now, is this one a function? Those open dots are like holes in the graph. And as you get into advanced math courses, you end up sometimes having a hole in the graph because of various reasons. Usually it's because of a possibility of division by 0. But how about this one? Is this a function? Yes, because those open dots, open circles, however you want to phrase that, those are like holes. And so it is a function because I can draw a vertical line and it will, I thought there was a vertical line there, but if I draw it right here, it's going through 2 holes. It's not touching at all. So that is a function. All right, so it's usually at this point that somebody raises their hand and says, well, I know there's a vertical line test. Is there such a thing as a horizontal line test? Once again, in later math courses, you will use something called a horizontal line test. And it's usually used to test whether the inverse of a function is also a function. And we're not concerned about that right now, but in another math course or two, the horizontal line test will come up. Okay? All right, so summary. If you have ordered pairs or mappings, each input has only one output. That tells you it's a function. For a graph, if a vertical line crosses your graph more than once, it is not a function. Once is a function. Quickly, turn to your shoulder partner. What did you learn today?